Edward Condon was born on March 2, 1902, in Alamogordo, New Mexico. His family were devout Quakers, and he would maintain his Quaker religion for life. When Condon was 5 years old, his family moved to the San Francisco Bay Area, and this is where Edward Condon would spend his youth and teenage years. A young Edward Condon's major interests were science and writing, and in high school he was on the debate team and also wrote for the Berkeley High School newspaper. Edward Condon graduated from high school in 1919. After graduating from high school, Edward Condon worked as a journalist for the Oakland Inquirer. Being a journalist, Condon witnessed corruption at the hands of politicians, and he became disgusted with the state of the world. He saw city leaders and politicians lie with no remorse or repercussions, often at the detriment of those in society with no means to defend themselves. Edward Condon's time as a reporter coincided with the Bolshevik Revolution in Russia and the thrusting of communism onto the world stage. Edward Condon was sympathetic to some of the values espoused by the new Soviet government, a fairly common sentiment amongst academics at the time, especially in the San Francisco Bay Area. But along with the Soviet Revolution came the first Red Scare in America, an extreme paranoia of communist agents amongst the American populace. And this political climate would eventually prove detrimental to Condon. Edward Condon was tasked with covering a local labor movement in which the police had framed some of the members of the movement with crimes they had not committed. Condon was called upon by the police department to testify against the leaders of the labor movement, and he refused. This refusal led Condon to becoming the target of harassment from the local police, and he soon would quit being a reporter altogether and lean into the physical sciences. Condon would say, quote, "The effect of this involvement on me was to wipe out any desire to be even an educated newspaperman, so I entered the university and went into physical science, largely as a means of escape from the corruption of the world, in addition to the fact that I was genuinely interested in physical science." In 1921, after 3 years of journalism, Edward Condon enrolled at UC Berkeley in their College of Chemistry. After a year of chemistry, Condon would run into one of his old high school teachers, who had recently joined the physics faculty at Berkeley, and because of this run-in with his old teacher, Condon would change his life's trajectory and take up a new major, theoretical physics. Edward Condon was soon immersed in the world of physics and theoretical physics. At its core, physics is a branch of science that studies matter, momentum, force, energy, and the ways that they interact and behave through space and time. There are many subfields of physics, like classical mechanics, which describes the behavior of solids, gases, and fluids; thermodynamics, which deals with the properties of heat, work, and temperature; electromagnetism, which deals with the properties of electricity; optics, which studies the behavior and properties of light and the electrode; and there was Edward Condon's major, theoretical physics. Theoretical physics is a subfield of physics that employs mathematical models and abstractions of physical objects and systems to rationalize, explain, and predict natural phenomenon. During this time, the field of physics in America was in its infancy and underdeveloped when compared to Europe. According to Condon, in the 1920s, most Americans didn't even know what physics was. Nevertheless, Berkeley would go on to develop one of the best physics programs in the country, and along with Edward Condon, Berkeley would come to foster physics minds like Ernest Lawrence, J. Robert Oppenheimer, and Philip Morrison. At Berkeley, Edward Condon received his undergraduate degree in theoretical physics in 1924, then PhD in physics in 1926. After completing his PhD, also in theoretical physics, Condon would decide to further his education in one of the physics capitals of the world, Germany. In 1926, Edward Condon arrived in Germany for a 2-year teaching fellowship, where he studied at the University of Gutenberg. Condon would grow close with fellow American physicist J. Robert Oppenheimer, who was also in Germany to further his physics education. Condon and Oppenheimer enjoyed Germany and all of the cutting-edge physics they were absorbing. At this time, Germany was one of the physics epicenters of the world, and physicists like Erwin Schrödinger, Werner Heisenberg, and Max Born were pioneering a new field of physics called quantum mechanics, a subfield of physics that describes the behavior of atoms and of the particles and forces that compose atoms. Quantum mechanics was created to account for the newly established quantum model of the atom. In order to better understand what quantum mechanics is, let's briefly review the history of man's understanding of the atom and the different atomic models that were developed over time. The word atom is derived from the ancient Greek word atomos, which means uncuttable. The earliest concepts of the nature of the atom were debated in ancient India and ancient Greece. The modern atomic model would begin to take shape nearly 2,000 years later. In 1803, John Dalton created the first modern atomic model, the solid sphere model. He theorized that different elements were composed of entirely different atoms, which had different properties. Atoms from different elements can form compounds, creating new properties, but the atoms themselves would not change. This early atomic model was thought to describe the smallest unit of a substance and had no subatomic particles. Through various instrumentations, scientists were able to determine the mass of different atoms, and this is what would form the basis of the periodic table. Different elements had different atomic mass and different properties. Some of the next major discoveries would occur around the turn of the 20th century. In the 1890s, it was discovered that while most naturally occurring atoms were stable, some elements with the large atomic mass like uranium or radium were unstable and would spontaneously release energy, referred to as rays, and change their atomic mass without outside influence, becoming a new atom. This process would be called radioactive decay, and the residual energy released would be called radiation. There were 3 different types of radiation discovered: alpha, beta, and gamma, each with different energy levels and able to penetrate different kinds of substances. This radiation process indicated that atoms were not the smallest unit of a substance, but that atoms were composed of even smaller subcomponents. Through experimentation, it was discovered that atoms were composed of positive and negative charges. The electron was first identified in 1897. Electrons are subatomic particles with a negative charge. To account for the discovery of negative and positive charges within an atom, the atomic model was updated to the plum-pudding model in 1904. The plum-pudding model theorized that atoms were composed of both positive and negative charges. In the plum-pudding model, atoms contain the recently discovered negatively charged subatomic particles, electrons, and these were thought to be scattered across a positively charged sea. In 1911, Ernest Rutherford discovered the proton, a subatomic particle that contained a positive charge, and that were nearly 2,000 times more massive than electrons. To account for protons and other discoveries, the atomic model would be updated once again to the nuclear model. The nuclear model theorized that positively charged components of an atom did not exist in a plum-pudding sea scattered across the atom, but rather the nuclear model stated that positive charges found in atoms were located in subatomic particles called protons. And these protons were contained in a small central component of the atom called the nucleus. The protons contained within the nucleus were determined to be held together by an intensely strong binding force. In the nuclear model, the negatively charged electrons were now positioned in an orbit around the proton-filled nucleus. The electrons were held in place with a binding force as well, though not as strong as the binding force holding together the protons within the nucleus. The number of protons in a nucleus is called the atomic number and determines the identity of an atom, and the periodic table was now organized based on atomic number instead of atomic mass. And the electrons orbiting a neutron would determine how an atom would interact with other atoms. Atoms of different elements could interact with each other through the sharing or taking of electrons and forming of molecules. The opposing positive and negative forces of the protons and electrons attracted each other and helped keep this orbit in a fixed position. The opposite is true for subatomic particles with the same charge. strong forces prevented outside subatomic particles with the same charge from connecting, making it nearly impossible to use protons and electrons as tools to manipulate atoms, because they would be repelled by these strong positive and negative forces. In 1913, Niels Bohr introduced the planetary model of the atom, which stated that electrons orbiting a nucleus were doing so in orbits of fixed sizes and energy. And in 1919, a major discovery was made. Scientists took alpha radiation particles from radioactive decay that we covered earlier and bombarded nitrogen, and were able to penetrate the nuclear forces in the nitrogen gas into an isotope of oxygen. This changing of a nitrogen atom to an oxygen isotope accomplished the first artificial transmutation of an atom, the first artificially induced nuclear reaction of an otherwise stable element. There were some limitations to this method, however. The alpha radiation particles could only penetrate light elements, and alpha particles were unable to penetrate the nucleus of elements with higher atomic numbers. In 1926, when Edward Condon was beginning his physics career, the atomic model was once again updated to Schrödinger's quantum model. Like previous models, the quantum model theorized that the atoms consist solely of a central nucleus containing positively charged protons, and orbiting the nucleus are negatively charged electrons. Schrödinger's quantum model would differ from previous atomic models by theorizing that subatomic particles move so erratically it was impossible to know their exact locations and momentum at a given time, and that the electrons orbiting the nucleus at different energy levels were doing so in clouds of probability. Since the nature of subatomic particles in the Schrödinger model are rooted in approximations that could not be represented by classical physics and mechanics, quantum mechanics was developing to account for this nature that relied on probability and approximations. Quantum mechanics utilizes probability to measure approximations of a given particle's energy, momentum, and other physical properties. And quantum mechanics would employ wave mechanics as well as matrix mechanics, which used algebraic matrices to represent the different states of subatomic particles. Edward Condon and Robert Oppenheimer enjoyed their time in Germany. They were on the cutting edge of physics, studying under European scientists pioneering quantum mechanics. Both Oppenheimer and Condon were quick learners and highly proficient in quantum mechanics and quantum theory, and before long it was time for Edward Condon to return to America with all he had learned. Using the knowledge he obtained in Germany, Edward Condon began touring US universities, helping bring knowledge of quantum mechanics to the United States. In 1929, in cooperation with Philip M. Morse, Edward Condon wrote Quantum Mechanics, the first English-language text on the subject, and Condon was credited with discovering the Condon-Shortley phase, the Frank-Condon principle, and the Slater-Condon rules, all principles of quantum mechanics that are still used today. Before long, Edward Condon was a nationally recognized leader in atomic physics and quantum mechanics. Edward Condon joined the American Physical Society, the American Society of Photogrammetry, the National Academy of Sciences, and the American Association for the Advancement of Science. Edward Condon became a professor at Princeton, which had one of the leading physics programs in the country. At Princeton, he would become acquainted with fellow physics professor H.P. Robertson, who would later run the CIA's Robertson panel. In 1932, while Condon was still at Princeton, another revolutionary discovery would be made to the structure of the atom: the discovery of the neutron. The neutron is a subatomic particle that contains no charge, and is positioned in the nucleus along with positively charged protons. The negatively charged electrons were still orbiting the nucleus in fixed orbits. Since the newly discovered neutron has neither a positive or negative charge, neutrons would not be repelled by the strong forces that affected protons and electrons, and it was discovered neutrons could bombard most elements, unlike the alpha radiation, which could only manipulate elements with low atomic numbers. Neutrons were able to penetrate the nuclei of elements with larger atomic numbers, and because of this, neutrons could be used as a tool in ways that other subatomic particles could not be.
Imagine that this billiard ball is a proton. No stream of light particles like electrons, no known type of wave, could have any more effect on such a body than these right grains have on the billiard ball. But another particle of equal mass would share its energy on collision, just as this second ball imparts half its energy to the first as it pushes it away. A particle of unit mass, but without electric charge, and so very difficult to detect.
Scientists soon began taking the newly discovered neutron and bombarding different elements of the periodic table. Often these experiments would result in the creation of separate isotopes for a given element, or combining and transforming elements into completely different substances. The process of nuclear fusion would be discovered during this time, the combination of two lighter atoms or particles into larger ones. And this process would create new substances, and often some particles and energy would be released in the process. The discovery of the neutron in nuclear fusion raised the relative significance of atomic physics and quantum mechanics. And like many physicists following the discovery of the neutron, Condon's interest would turn towards nuclear physics. Edward Condon focused on the applications of new methods of quantum mechanics to problems of atomic and molecular structure, and the interpretation of radioactivity. By this point, theoretical and quantum physics had gone from obscure sciences most Americans had not heard of, to well-known sciences with broad, practical applications. In the 1930s, physicists were responsible for major advancements in radar, FM and AM radio, the first Xerox copying machines, new kinds of long-lasting batteries, and many other things, and physicists were in hot demand. Edward Condon would leave academia in 1937 to work at Westinghouse Electric and Manufacturing Company, and while there he would invent a device called the Nimitron. The Nimitron was a machine that recreated the ancient math game called NIM. This device was revealed at the 1939 New York World's Fair, and the Nimitron machine was credited with being one of the first machine games, and first examples of machine's ability to represent data. Although the Nimitron was popular at the World's Fair, it was too expensive to mass produce and sell, and with World War II looming on the horizon, Condon focused on research and development of microwave radar and nuclear physics.
Japan has brought 55,000 more troops up the Yangtze River. And as the Chinese armies mass in a great arc around the city's western outskirts, it's war within a few months.
Germany has invaded Poland and has bombed many towns. General mobilization has been ordered in Britain and France.
When World War II broke out across the globe, many of America's prominent scientists would go into research and defense. Edward Condon would help organize President Roosevelt's National Defense Research Committee, a scientific research and development effort led by Vannevar Bush. Edward Condon also helped MIT organize their infamous Rad Lab, which featured scientists like Carl Compton, Ernest Lawrence, and John Trump. In Europe, atomic physicists made another very important scientific discovery. When neutrons were bombarded against certain isotopes of the unstable elements uranium or plutonium, something interesting would occur. It was discovered that if certain unstable isotopes of uranium or plutonium were bombarded with neutrons, it would result in the breaking of the atom into multiple smaller and more stable elements. This was initially unexpected due to the extreme binding energy of the nucleus. This atomic splitting process would have a side effect of releasing a large amount of nuclear binding energy, and this process would also release stray neutrons. This process would come to be known as nuclear fission. To compare nuclear fusion and nuclear fission, as it was understood at the time, nuclear fusion is the combination of two lighter atoms or particles into larger ones. Nuclear fission occurs when bombarding certain unstable elements, like uranium or plutonium, with neutrons results in the splitting of atoms into two smaller atoms. And this process would release a noticeable amount of energy and stray neutrons. Furthermore, it was theorized that if you were able to get a large enough quantity of uranium or plutonium and attempted nuclear fission, the neutrons and energy that were released in the initial splitting of the atoms would go on to bombard nearby atoms, causing the splitting of these nearby atoms, releasing more energy and more neutrons. And this process would repeat and repeat, causing a chain reaction. And this chain reaction would release a huge amount of energy. And it was theorized that it could create an explosion bigger than any chemical reaction. One saving grace regarding this theorized superbomb was that the specific isotopes of uranium and plutonium needed for the desired fission process were very rare and extremely expensive to produce quantities that would lead to the desired result. Nevertheless, the race to an atomic bomb had begun, and American scientists watched nervously from the sidelines. Japan's attack on Pearl Harbor, America officially joined World War II. There was a massive mobilization effort, and all aspects of American society honed in and focused on winning the war. Amidst this climate, Edward Condon began hearing rumors amongst his scientific colleagues that a top-secret project was being organized to build off of the discovery of nuclear fission and split the atoms of uranium or plutonium to harness the power of the energy released in the chain nuclear reaction and create the theorized superbomb. And soon, these rumors would come knocking at Condon's door. J. Robert Oppenheimer, Condon's fellow Berkeley alumni, who studied with Condon in Germany, showed up and asked Condon if he would join him on a top-secret project that would come to be known as the Manhattan Project, the massive scientific project to create the first atomic bomb. The Manhattan Project composed of some 130,000 workers, various project sites around the country, and a budget of billions of dollars, and J. Robert Oppenheimer had been tasked with helping organize this effort. J. Robert Oppenheimer recruited Condon to be the associate director of Los Alamos, one of many sites around the country which were taking part in the Manhattan Project. Condon helped select the Los Alamos site in New Mexico. An interesting coincidence is found in that Los Alamos was close to Edward Condon's birthplace of Alamogordo, New Mexico. Edward Condon helped Oppenheimer select the Los Alamos staff, and Edward Condon prepared a document on nuclear physics called the Los Alamos Primer that all the new scientists at Los Alamos were to read upon arrival. Edward Condon was working as an assistant director to one of history's most seminal scientific undertakings. According to physicist Edward Teller, Condon was single-handedly responsible for shortening the length of time to the eventual H-bomb by 1 whole year. There is something else worth bringing up. In my researching Edward Condon, I was surprised to learn that he had many tangential, possible run-ins with UFOs prior to his taking the Air Force contract in the late 60s, nearly 20 years later. One example can be found in his founding of Los Alamos, and the role Los Alamos National Laboratory has played in UFO lore, as well as all of the UFO sightings reported around the various Manhattan Project sites like the Hanford site and Oak Ridge. Another interesting point to note is that the language in the 2023 NDAA seems to indicate that UFOs were spotted and perhaps recovered near the Trinity test site, where the Los Alamos scientists would eventually detonate the first atomic bomb. Now there will be a few more of these interesting brushes with UFOs that Condon would have. Nothing confirmed, but UFO history lovers will find these tidbits interesting, so just keep these in a side box going forward. The brutality of World War II, along with intelligence reports that the Germans were close to developing the atom bomb, motivated the Manhattan Project scientists to put all they had into reaching the bomb first, without much regard for the implications and effects an atomic bomb would have on the world.
I have been asked whether, in the years to come, it will be possible to kill 40 million American people in the 20 largest American towns by the use of atomic bombs in a single night. I am afraid that the answer to that question is yes.
Amidst this patriotic and urgent climate, under which the Manhattan Project scientists worked, Edward Condon would go against the grain and be one of the first American scientists to raise the question of whether civilian scientists or the military should be responsible for overseeing atomic energy. A point of contention for Edward Condon was that he did not think that the military should be the sole group responsible for this new weapon that was going to be unleashed on the world. Condon's problems would be compounded by the secrecy that the military put under the Manhattan Project scientist. Condon was angry that scientists were not allowed to consult other scientists also working on the project, which made progress difficult. Edward Condon clashed with General Leslie Groves, the Army Corps of Engineer officer overseeing the construction of the Manhattan Project. Because of these concerns, Edward Condon would resign from the Manhattan Project. In his resignation letter to Oppenheimer and the military officials overseeing the Manhattan Project, Edward Condon would say, quote, "The thing which upsets me the most is the extraordinary close security policy. I do not feel qualified to question the wisdom of this, since I am totally unaware of the extent of enemy espionage and sabotage activities. I only want to say that in my case, I found that the extreme concern with security was morbidly depressing, especially the discussion about censoring mail and telephone calls." Edward Condon's departure from the Manhattan Project in the midst of World War II was one of the first examples of scientists and the military clashing over who would control and decide how the atom and atomic energy would be used. But more scientists would come to the position of Condon once the power of the atom bomb was actually witnessed.
Correspondents at Air Headquarters on Guam, including CBS's Webley Edwards, though they could not attribute it to any specific source, were allowed to say there is reason to believe that the Japanese city of Hiroshima, approximately the size of Memphis or Seattle or Rochester, New York, no longer exists. General Sputz smiled when asked if the new atomic bomb would be dropped again in the near future, but every indication is that it will be, for he announced that more B-29s are ready to follow the Pathfinder which hit Hiroshima, and that the atomic bombers would operate Air Force bases in the Marianas.
After witnessing the horrors unleashed on Hiroshima and Nagasaki, many atomic scientists began to flock to the Edward Condon camp of a need for serious addressal on the use and oversight of the atom. And because of his early departure from the Manhattan Project, Edward Condon became a scientist that other scientists sharing his sentiments flocked to. Edward Condon, along with like-minded atomic scientists like Philip Morrison and J. Robert Oppenheimer, would be instrumental in organizing civilian atomic scientists to lobby and serve as scientific advisors to congressmen with the hope of putting atomic energy in the hands of civilian scientists and not the military, now that World War II was over and the Manhattan Project was dispersed. Condon served as scientific advisor to Senator Brian McMahon, who drafted the Atomic Energy Act of 1946. This act ensured that atomic and nuclear technology in America would be managed by civilians and not the military. The Atomic Energy Act of 1946 created the United States Atomic Energy Commission, and this government organization would eventually become the Department of Energy, long suspected of UFO connections. It is interesting that Edward Condon was largely influential in the creation of the Department of Energy, another unexpected Condon UFO overlap. Edward Condon was then appointed director of the National Bureau of Standards in 1948 by President Harry Truman. What is the National Bureau of Standards? Well, when the National Bureau of Standards was founded in 1905, there are at least 8 different gallons and 4 different feet in use, and this government organization was responsible for standardizing proper measurements on these and other matters. They were also one of the government's only scientific organizations at the time, and they partook in the Manhattan Project as well. While Condon was the director of the National Bureau of Standards, the National Bureau of Standards created the world's first atomic clock. Condon's time with the National Bureau of Standards also has some unexpected UFO overlap. An associate of Condon's at the National Bureau of Standards was Harvard astronomer Dr. Donald Menzel, and during this time, Menzel was doing contract work debunking UFOs for the Air Force. Another unexpected UFO overlap during Condon's time running the National Bureau of Standards is that during Condon's tenure, Major Aaron Boggs and Captain Robert Snyder, both project officers for Project Sign, the Air Force's first public UFO investigation, gave a briefing to the National Bureau of Standards on various UFO incidents, and later sent over incident summaries at the request of Colonel McCoy, who oversaw intelligence at Wright-Patterson Air Force Base. We have members of Project Sign, the Air Force's first UFO investigation, briefing the National Bureau of Standards in 1948, when Edward Condon was the president and when Donald Menzel was his associate. During this time, Edward Condon also served as an advisor to the National Advisory Committee for Aeronautics, a precursor to NASA, and things were looking up. But soon, Condon would get caught up, once again, in a Red Scare. In 1948, during the McCarthy era, Dr. Edward Condon was one of many atomic scientists accused of communist sympathies. This was largely influenced by his time in the San Francisco Bay Area covering labor movements, his early departure from the Manhattan Project, his role in the creation of the Atomic Energy Commission, some of his wife's associations with suspected Soviet spies, and his participation in the American Soviet Science Society, a Rockefeller-funded international science group that Condon claims he joined out of belief that science should be beyond countries. Edward Condon was investigated by the Loyalty Review Board, and his preliminary loyalty interview was conducted by future President and then Congressman Richard Nixon. Here in these hearings lies another unexpected Condon UFO overlap. It should be noted that there are some researchers who claim that along with the anti-American and anti-communist sentiments that fueled the McCarthy hearings, there were also UFO underpinnings to these hearings when considering who was questioned and about what and during what years. This is a topic for its own video, but there is a quick Condon point that I want to highlight. This memo is referred to as the Guy Hoddle Memo. It was drafted in March 1950 by FBI agent Guy Hoddle, who was at that time the head of the Bureau's Washington field office. His report relays an account said to have been given by an Air Force investigator who claimed to have recovered a trio of flying saucers with crew intact. This document has caused quite a stir in recent years, being the most viewed file on the FBI's website, and various explanations have been concocted to explain it away. Nevertheless, this same Guy Hoddle, who wrote the March 1950 memo about crashed UFO retrievals, also wrote a majority of the reports and conducted field investigations on Edward Condon and his wife for his FBI file as a part of the Red Scare. Another interesting, unexpected UFO Condon overlap. Amidst these McCarthy investigations, Edward Condon was hauled before the House Un-American Activities Committee.
Have you ever been a member of the Communist Party? Are you a member of the Communist Party? Are you a member of the Communist Party?
Many prominent scientists would publicly support Edward Condon, including Edward Teller and Albert Einstein. Edward Condon became a rally point for the American scientific community and those wishing to see scientific freedom. Edward Condon became a symbol of scientific freedom in America, and this would be demonstrated by the American Association for the Advancement of Science. America's oldest national civilian science organization would eventually elect Condon as president. And at the 100-year centennial celebration of the American Association for the Advancement of Science, President Harry Truman gave a speech with Edward Condon and other atomic scientists that were caught up in the Red Scare seated behind him. President Truman made a point to emphasize the importance of scientific freedom and a government that promotes and cooperates with scientists.
Members of the American Association for the Advancement of Science, ladies and gentlemen, the second obligation of the federal government in connection with basic research is to provide working conditions under which scientists will be encouraged to work for the government. Scientists do not want to work in ivory towers, but they do want to work in an atmosphere free from suspicion and personal insult or politically motivated attacks. It is highly unfortunate that we have not been able to maintain the proper conditions for best scientific work. It was highlighted by a telegram I received last week from 8 distinguished scientists. These men expressed their alarm at the deterioration of the relations between scientists and the government because of the frequent attacks which have been made on scientists in the ostensible name of security.
In the 1950s, when Condon's life was getting back to normal, he was once again investigated by the House Un-American Activities Committee. This time around, J. Robert Oppenheimer was being investigated as well as their fellow Berkeley alum and atomic scientist Philip Morrison, 3 of the most prominent anti-war atomic scientists. Oppenheimer had also had connections to Berkeley communist groups through his wife and his brother, and Oppenheimer's opposition to the development of the hydrogen bomb deemed him un-American. And Philip Morrison had been a card-carrying communist. As a result of the next round of Atomic House Un-American Activities Committee hearings, Edward Condon, Philip Morrison, and J. Robert Oppenheimer would be stripped of their clearances and be unable to work on classified projects. Following the McCarthy hearings fiasco, Edward Condon would resign from the government, losing his clearances, and transition to academia and eventually the University of Colorado, where in 1966 he would take the Air Force UFO contract to study UFOs and Project Blue Book, his first official post with the government since the Oppenheimer trial. Many UFO enthusiasts felt good about the announcement of the University of Colorado and Edward Condon, hoping that his past examples of sticking to his scientific principles would carry through into this study. This project looked promising. It was to be free of Air Force or intelligence interference, and the FAA was now to forward their civilian and commercial UFO reports to the Condon Committee. The announcement of the Colorado study run by Edward Condon, combined with the new public advocacy of James McDonald and the former Air Force debunker J. Allen Hynek, completely energized the UFO community. UFO groups around the country saw surges in membership. And that year's UFO Congress was the largest on record. And J. Allen Hynek would celebrate the appointment of Condon with his family, feeling vindicated that scientists were finally the ones looking at UFOs and not the Air Force. And soon, the Condon Committee was underway.
The white star over there got really bright, a really brilliant white, and it lit up the whole field. You could see everything.
I was flying at the time I saw this U.S. so-called UFO.
I'd say that the greatest difficulty about getting anything
we set up all kinds of elaborate mechanisms to have people.
We would welcome not